So here again I've got a very generic looking equation, and this time I want to go deeper into the solutions by substitutions, and this one here is that dy dx is some function that is linear in x and y. And for this kind of equation in particular, the method that I want to emphasize is known as reduction to separation of variables. So as the name might suggest, once the proper substitution is employed, this will then become a separable equation, which can then be solved using separation of variables. And so we have a linear function of x and y. So if we wanted to come up with an effective substitution that would make this a separable equation, recall from single variable calculus that when you had something linear, say if you define u to be a linear function of x, for instance, then du would just be a scalar multiple of dx. So that's ideal here. That way, if we can get dy dx to be a scalar multiple of some other derivative, then we could potentially come up with a separable equation that wouldn't be bringing any other variables into the equation. So now let's say w is equal to ax plus by plus c. And if w is equal to ax plus by plus c, then that essentially means that dy dx is really just f of w. Now let's consider the function w. W is ax plus by plus c, and a, b, and c, they're just arbitrary constants. So let's just say now that, well, for starters, recall from the other methods that involve solutions by substitution that in this case we are differentiating implicitly. So if we took the implicit derivative of our function w of x and y, dw would then be equal to dx plus dy. So now if we wanted to substitute for dy dx, we could divide the dx and we would end up with that dw dx is equal to 1 plus dy dx. So now with that being said, dy dx is equal to dw dx minus 1. So let's go back into our equation now and let's substitute that value in. So dy dx, let me change colors here. Let's switch to yellow. So dy dx, that is equal to dw dx minus 1, and that's f of w. So now we have here that dw dx minus 1 is equal to f of w. So that would mean that dw dx is f of w plus 1. So at this point we can multiply out the dx. So dw is f of w plus 1 times dx, and this is all a function of w, the f of w plus 1. All of this right here depends entirely on w and nothing other than w. It doesn't depend on x or any other variable. So then we could divide it and we would end up with dx equals dw over f of w plus 1 And at this point, we could then integrate both sides, or we could even set it equal to 0, integrate everything then, and the integral of 0 is a constant, the constant of integration. Nevertheless, you would end up with x equal to the result of this. And this was a very generic example. So here I want to do a hands-on example. Actually, I think I'll do that in the next video.